Welcome Year 10s to this video. In it I'm going to take you through the last few examples that are in your notes for simultaneous equations. So it's a continuation of what we started looking at last week. I'm going to take you through this first one here where we are going to graph like we did in our last example, the one with the football membership. We're going to look at this one, which is just a slightly different context, but you're going to see similarities in what we do. And then in the last couple of examples, we're not going to use a graph for these ones. We're just going to have a go at trying to set up the equations we need. And we're going to use our calculator to solve from there. So with this first one, what you'll notice is we are given some information about two different things. In this case, it's two different plants, and these plants have been purchased by Jennifer, and they've got different heights when they were first purchased. So we've got the fiddle leaf fig, which was initially 40 centimeters tall, and we've also got how fast it's growing. So it's got 0.2 centimeters per week. The other plant, though, has a different height. So its initial height when it was purchased, only 32 centimeters tall. But what you'll see is that it's growing faster. It's growing at 1 centimeter per week. So what we want to do first is get this information into two equations. First of all, see how it's got here growing at a rate of. You might remember that rate, when we see that word, or when we see a rate in the question, it's likely that it's talking about or it's referring to the gradient in our equation. So straight away, I'm looking at that and I'm thinking, okay, if it's 0.2 centimeters per week, and I'm going to use n for weeks since I'm told to here, means that the height is going to be 0.2 by n, so by however many weeks. But we also want to add on to that height what it started off as. So the fiddle leaf fig started off with a height of 40 centimeters. So if we put the plus 40 on the end, of course that's our y-intercept. Then we've got our equation now. We've got our gradient and we've got our y-intercept. We've got our height because if you consider after 1 week it'll be 40.2. After 2 weeks it'll be 40.4, etc. We can do the same with the Swiss cheese plant. So we've got it's growing at 1 centimeter per week. So that would be 1n, but we can just write that as n. Just make a note that 1n is the same as writing n. And that's initially 32 centimeters tall. So we'll add the 32. So however many weeks, say it was 3 weeks, that means that it would have grown 3 centimeters plus the 32. So it would be up to 35 centimeters at that point. So there's our two rules. We've got h equals for both since we're talking about height. And we're asked what does the gradient of these equations represent. So keep in mind that this part here is our gradient. This part here is our y-intercept. And I mentioned before that the gradient is the rate. So there'll be a rate in your question. There'll be something happening, say per dollar, per week, per whatever unit it is. And so we want to just describe that in words. So it's really, if you look up here, it's got growing at a rate of. So we could use that particular language. It's the growth rate of each plant. The y-intercept, or if you have a look at what we've added, we added 40 for the fiddle leaf fig and we added 32, and that was that initial height of the plant when it was purchased. So I write initial height, but we mean, of course, height when purchased. Or the height when n is 0. That's another way to look at it. Height when n equals 0. So when no time has passed, in other words. Okay, now that we've got our two rules, you'll see we're going to be graphing them, just like we did with the previous example. We want to get both of these graphs on the same set of axes. So we'll go over to our calculator. Before I do that, I'm just labeling. I've got my h-axis for the height and my n-axis is for the number of weeks. You'll notice we have been told to do this between 0 and 15, which is already written on our scale for us. But if we didn't have the scale there, this here would tell me what to go to on the n axis or the x axis. And to know what I'd have to go to on the h axis, I'd first have a look at my graphs on my calculator screen so I could see what values the height was for each plant at this point, just so I know how far up this axis do I need to go. Okay, so just keeping the equations in mind, I need to move across to the graph page now. So I'll put the first one in. It was 0.2. Now it's not going to be n, so don't do this because then you won't get a graph come up. The n equivalent is the x-axis, so I'll put that in, and then I'll put plus 40. Now when I press enter, you'll see I can't see it. I can't see it because it's further up the window, so I'll just press menu, window, and I'll go zoom fit so I can see it better. So there it is. It's got the y-intercept of 40, so that's why I couldn't see it. The other one, I need to put the second one in, so I'll press tab and we'll see F2 comes up. So the next one was n plus 32, I think. I'll just double check. Yep, n plus 32. So we'll press enter. Oops, that. Try that again. I didn't want n, I wanted x, that's why it didn't work. X plus 32, press enter, and as we can see, the y-intercept is much further down, that's why we can't see this one very well. We also can't see very well where they are crossing, so I'll just go back to my zoom fit, and that's a little bit better there. Now, the issue is I don't need all of this space over here because I don't need negative weeks. And as you can see, I can't see up to 15 at the moment. So to fix this, I'll go to my window settings up here and I'll change my x minimum maybe just to -2. I'll have a little bit of the negative there just so I can see the axis. And then I'll go up to 15. Now my y minimum, I might just go like -20, -10 maybe, just so I can see a little bit underneath that axis. And then the y maximum, I'm going to cheat a little bit because if you have a look over here, it's got, on this scale, it's going up to 55. So I'm going to go up to 55 on this one as well. So remember, it's just so that I can see the graphs. What I put on the page won't necessarily reflect exactly, won't look exactly like this because I've got a slightly different scale. But it's just so that I can see everything and then I can start getting my points and I can start putting them onto my graph. Now, if you get this, this stuff in your way, you can sort of click and drag it. So I've just done that just so it's not impeding what I want to see, which is this point of intersection, the two intercepts here, the y-intercepts, and I want to see where the graphs end as well. We call that the end points. Okay, so in terms of the y-intercept, well, I know that it's 40 and 32. I can see that from the graph. But if I use graph trace anyway, and I don't really want to scroll, so if I press 0, you'll see it takes me to this one, 0, 40. And then if I click the down arrow, it'll take me to the other one, which is 0, 32. So I'll just mark them in first. 0, 40 and 32, like so. Now I won't do the point of I'll do the point of intersection last because I'll get these end points first. Then I can just draw the two graphs and the point of intersection will be there. So I'll do this blue one first, which was our first graph, and I'm just going to type 1, 5, so it takes me to the value over here at the end point of the graph. So 1543 is what I want. So 15, and we start at 40, but it's then 41, 2, 3. So as you can see, this one hasn't grown by very much because it had a very slow growth rate. Whereas the other one, oops, Just press escape because it's doing something funny to me. Oh, I know, because I've got that, I've got F2 is actually the one I put in as N, the one that I mistakenly put in as N. So if we go back to graph trace, and now I'm on the black graph, so x plus 32, and press 1, 5. And there we have it, it's 1547. So there's 45 there, so 47 is up here. Okay, now what I'll do is connect those, if it allows me to. I might just have to do a little trick. Okay, so this one started lower and ended up high. I'll just adjust that. And then same with this one. Okay. And there's our two graphs. So obviously you should be doing this or pausing me if you need to and doing this yourselves as well on your copy. Okay, so I've got my two graphs in there. I might label them, and then what I'm going to do is I'm going to get this point of intersection because I have been asked to label that one as well. So this one here was h was 0.2n plus 40. And this one here was h equals n plus 32. There we go. So they're both labelled. And then I'm going to get this point over here. So what I'll do is I'll go back to this screen. And now I want to know the point of intersection. So this is where we go menu, analyze, and we want number 4, intersection. So remember, what you want to do is just find a little bit before the intersection and click, scroll sideways so that it covers the point of intersection, and click again. And then we've got our point of intersection, 1042. Now you can see my graphs aren't super accurate because it should have actually been here, 1042. So I might just move this over a little bit. Now the reason it's not super accurate, a couple of reasons. I've done these really big dots and my lines probably aren't going directly through the dot. So what you can do is that sort of thing just to make sure it is more, well, it looks a lot better to me if it's more accurate. And if need be, well, I can move my lines slightly, but don't worry too much as long as it's fairly rough, fairly close. Do what I did and just make your dot a tiny bit bigger just to show that we intended them to intersect across this 10 point. So it was 10 and 42. All right, so we do make sure that we label that as well. All right, finally, we've got our two graphs. Now we can interpret them. What does this point of intersection represent? So we need to think about the context and then refer to that when we're talking about this point. So we can't just say that the point of intersection is 1042. That just basically states it again, doesn't say what it means. So what we want to do is think about if we're looking at these two graphs, they're representing the height, but they're the height over time, so after a certain number of weeks. This point here is where the two graphs meet. So it's where our height is exactly the same. Just get rid of that. It's where our heights of the two plants is exactly the same. So it's telling us after 10 weeks, the two heights of the plants have the same height, and that height is 42 centimeters. So in terms of what it represents the point in time that the plants have the same height. So before that, the fiddly fig was taller. At this point, they're the same, but then after that, the Swiss cheese plant, the Monstera, is taller. So you see they've swapped, and they've swapped because one of them is growing faster than the other one. So we said what it represents, and then I guess just for more detail, after 10 weeks, they are both 42 centimetres tall. Okay, last one. After 15 weeks, which plant is taller? So if we have a look at this last section, so after the 15 weeks, this plant here, which was the N plus 32, the N plus 32 is our Swiss cheese plant. So I can say that it is the Swiss cheese plant that is taller. But we've also been asked by how much. So if you look up here, this one is 47, while the other one is 43. So we can say by, I'll just put a comma, 4 centimetres. And then we're done. So you'll see there are lots of similarities with what we've done here compared to what we did last lesson. Last lesson, we did this one up here where we had, again, two different equations, two different gradients, two different y-intercepts. We had to talk about or describe what the gradient represents. We graphed them. We showed the endpoints. We showed the graphs, the label on the graph, and we also showed the point of intersection. We then interpreted the point of intersection. We used it to help answer that question about which option would be better. Whereas here, we used it just to decide or just to have a look at A, what the point of intersection meant, and then B, which plant was taller. So that's probably enough practice just of graphing right now that we'll do together. And then the last exercise is just doing some further stuff with simultaneous equations. But with these ones, this is where you're actually going to be writing the equation. You're going to be jotting down two equations from scratch. So the other two questions are quite scaffolded. These ones aren't going to be. They're just going to be worded questions where you put together two equations. And you can use your calculator to solve from there on. So I'll show you some steps that you want to follow. First of all, you want to define the variables. So the things that you're trying to find, you're going to give them a letter. So give them a letter. You're going to form the equations. Probably the hardest part is step 2, writing down the equations. Then solving the equations, we're going to use the calculator. All right, use CAS, that's what we call the calculator. And then we're going to interpret the solution that we get. Make sure we answer in words just to ensure we've completely answered the question. So we've got Ashley received better results for her maths test than her English test. So we might assign that a letter in a second. If the sum of the 2 marks is 164, difference is 22, calculate the marks she received for each. So the marks she received for each subject, that's what we're trying to find. So I might just use X for maths mark, and Y is going to be the English mark. So that's what we call defining the variables, giving them a letter, stating what each letter means. Okay, let's get some equations. If the sum of the 2 marks is 164, sum meaning addition, so if she adds her 2 marks together, she'll get 164. So that's one equation already. We just need one more, and that's here. The difference is 22. Difference refers to subtraction. Now it says she got better results for maths. So that means I'll put maths first. Maths is higher than English. I have to do that because otherwise I'd get a negative if I did the difference. If I did her English mark, take away her maths mark, I'd get a negative number. This is telling me the difference is 22. All right, I've got my 2 equations. This is where I now will go to my calculator. So the steps we're going to go to now, I'll do it on the calculator, but if you go back here, these ones, we're going to do menu 371. and we're going to get this option come up. We're just going to type the two equations in. So I want a calculator screen for this. So press Control-I, add calculator, and then menu, we want to go 3, then 7, and then 1. So we've got two equations. They are x and y. We'll press enter, and they were x plus y equals 164. Let's double check that. Yep, and x take y equals 22. And we press enter. All right, and then we have our solution. So x is 93, y is 71. We can see the difference is 22, and we can see when you add them up that you get 164, so it works. So now we're just answering words. The maths mark is 93, and the English mark is 71. It doesn't say whether it is a percentage grade, so I'm just going to leave it as is. If it said percentages, then I'd put the little percentage symbol with these. It could be percentages, of course, but it may not be. Okay, so that's one example. So using this sum, the word sum and difference, they might use the words product. Product means multiplication. More commonly, you might get something come along like this last one that we'll look at. It's to do with buying an item and how much you buy of each item and how much it costs. So if you have a look here, we've got 25 nuts and bolts from a hardware store. That's what Genevieve has purchased. We've got the cost of each of those and how much she spent altogether, but we don't know how many of each that she's bought. So that's what we're going to try and work out now. So if I say X is the number of nuts and Y number of bolts. Okay, so what do we know? We know that in total there were 25 of them. So what we could do is add them together and we would have to get 25. The second equation's a little bit trickier, but once you see how I do this one, you'll be able to use this particular skill, apply it to other questions as well. Now, I'm noticing first that I've got this in cents. So is this one? Oops. It's not going to let me put a line under it. That one's in cents as well, whereas this one is in dollars. So you want to make sure when you are writing an equation that's going to involve cents and dollars that you get them into the same unit. So 12 cents is 0.12 and 25 cents is 0.25 in dollars. So what this means is if we want to make a rule that's got the total that she has spent using the number of nuts and the number of bolts, I would take the price of the nuts, multiply it by how many she bought, and I'd add that to the price. I'll just move this over. The price of the bolts, which was 0.25, multiplied by how much she bought. So then I'd get total cost of all the nuts here, and I get total cost of all the bolts there, and that has to equal the total that she spent, which was $4.30. And now from here, I've got my two equations. Once I've got them, I can solve them in here. Okay, so I've got two equations with x and y. X plus y equals 25, and then this one, 0.12x, 0.25y equals 430. Okay, and I'm get a nice answer here of 15 and 10. Now, just to note that if you didn't get a nice answer, you say you got a negative number, you got a number that just doesn't make sense, like if I didn't get a whole number here, I'd be wondering why. Because, of course, the number of nuts and the number of bolts would have to be a whole number. So that's sometimes a warning that there's a problem with one of your equations maybe, or a problem in what you've entered into the calculator. So just be careful. The number, and then we'll just answer in words. Okay, and there we have it. So I'll finish there so that you can get some practice, but do make sure that you are letting me know if there's any questions there that you're really struggling with that I might need to go through with the class on Wednesday, or of course you can always send me an email as well. Okay, thank you.